Well, hello and welcome to this exercise on parallel lines, Bidmas or Pemdas, proof and difference of two squares. Now, this is for the first one. This is our diagram in which we have two sets of parallel lines, the red set of parallel lines and the blue set of parallel lines. We're asked to find the values of x and y. Now, x first. Now for x, we are looking at the blue set of parallel lines, the BEG and the ADH. They have a transversal DEF, and they got an interior angle with a value of x and a value of 66 degrees. And the interior angles in this case, in this situation, add up to 180 degrees. Therefore, the value of x is 180 minus 66 degrees, and that will give us 144 degrees. Sorry, 114 degrees. Okay, right. And next for y, we want to find the value of y there. Now, firstly, we need to look at the red set of parallel lines first, the lines ABC, which is parallel to the line DEF. Now, these two lines have got a transversal BEG. Now, that being the case, this angle here, which is 114, will be equal to this angle because they are corresponding angles. So the value of angle B, or the angle EBA, is 114 degrees. Right. Next, we look at the blue sets of parallel lines. The lines BEG and ADH are parallel, and they got a transversal at AE. So that being the case, the alternate angles are equal. Now, do not say Z angles because you get it wrong. The alternate angles are equal. So that being the case, angle BEA is now 34 degrees. Now, for the triangle ABE, the angles in a triangle add up to 180 degrees. So the value of y is going to be 180 minus 114 minus 34, and we end up with the value of angle at y is 32 degrees. Now for the next question, it says work out the 10 cubed minus 4 times 15 squared. Now, because we got indices or exponents here, they got precedence over everything else within this bracket there. So we do that first, and 10 cubed is 1000 and 15 squared is 225. Now, following on from that, the multiplication has got precedence over subtraction, and 4 times 225 will give us 900. So we end up with 1000 minus 900, and that will give us 100. So the square root of 100 is 10, and that is the answer for this question here. Now for the third question, we're supposed to prove that 3n plus 1 all squared minus 3n minus 1 all squared is a multiple of 4 for all positive integers of n. Now, you can decide, you can expand this if you wish, and then expand that, and then add those, and then subtract. But we can do it another way. If you think of our perennial difference of two squares, because here we got squared here minus another squared there, so similar to a squared minus b squared. And of course, a squared minus b squared is a plus b multiplied by a minus b there. So this will then become 3n plus 1 plus 3n minus 1, which is a plus b, multiplied by 3n plus 1 minus 3n minus 1. Now, because that's minus there, when you open on the brackets, that becomes, we change the minus 1 sign to plus 1. So we now end up with 6n from there times 2 from there. So 6n times 2 will give us 12n, and we can factorize 12n as 4 into 3n. So anything that's a multiple of 4 is anything with a multiple of 4 also has 4 as a factor. So in effect, this is a multiple of 4. And I hope all that made some sense, and thank you for watching. Please subscribe, and I'll see you again sometime. Bye bye now.